Hi, welcome to 10.4, lesson on solving radical equations. Before you watch this video, be sure to watch the video in Schoology on how to actually do this. I'm just going to be reviewing the steps here in this video and then focusing on rationalizing the denominator. But the video on Schoology will actually show you how to do this. So a few things to keep in mind. When you're solving typical radical equations, you want to get the radical by itself because most often in a radical equation, the variable is under the radical. Then square both sides, and then lastly, be sure to check your answer. So the typical radical equations you'll see has the x under the radical, and that's why you want to get the radical by itself and isolate it. Now, always keep in mind checking your answers. The number that's under the radical can't be negative. Think about the square roots that you know. For instance, back to this sheet. All of these square roots equal a positive solution. So this can't be negative. So if you end up isolating the radical and it says it's equal to something like -6, and then you proceed to, all right, square both sides, both sides you square it, you're going to end up with an answer that's not true. That doesn't work. Because you cannot take the square root of something and get a negative number. So always be sure that you check your answer. Just in case you miss this happening, you want to double check your answer, plug it back in, and then you'll see, oh, it didn't work, then that must be no solution. Okay. We're now going to be taking a look at examples number 7 and 8 in your notes. So here we have a radical equation where the x is not under the radical. So the goal here is to solve the equation for x. And you see that x is being multiplied to the square root of 3. So to get x by itself, I would have to divide by the square root of 3. And I know that that would make 1, bringing down x. But then over here on this side, I would also have to divide by the square root of 3. Now, I'm not going to use a calculator to get a decimal answer here. I'm going to simplify. Now, you know that the answer can't be 20 over radical 3 because I can't have a radical in the denominator. So I'm going to have to rationalize the denominator like we learned before. So to do that, I would multiply by radical 3, top and bottom. Remember, that's really the same as multiplying by 1, which is then going to give me 3 in the denominator, and then 20 times radical 3, 20 square root of 3. And that would be my solution for x. Simplified solution without a radical in the denominator. Okay, here on number 8, same type of thing. I want to isolate the x, solve for x, get the x by itself. Notice how the x is not under a radical, but it is being multiplied to radical 2. So to get the x by itself, I divide by square root of 2. That would cancel, and I bring down the x. But this means I have to divide this side also by square root of 2. Now, the problem over here is that I can't leave my answer like this. I can't have a radical in the denominator. So I'm going to have to rationalize the denominator. So with this one, since I have a little bit more room, I'm just going to bring it down. Okay, that's not simplified yet. So let's multiply by square root of 2 over square root of 2. And then I know, we're going to bring this down, square root of 2 times square root of 2 is going to be 2 in the denominator. And then here I have 9 outside the radical. And inside the radical, square root of 2 times square root of 3, which would be square root of 6. And so I end up with 9 square root of 6 over 2. Now I just want to double check to be sure the 9 and the 2 can't be simplified, and it cannot. They don't have common factors. 6 can't be simplified or broke apart in the radical, so this is completely simplified without a radical in the denominator. So that is how you solve radical equations where you need to rationalize the denominator. Thank you for watching.